Hello all, welcome to Embedded Linux Learning Point, Linux from Scratch 11.1, episode 21. Okay, now that we have built Python 3.10 and installed it, let's build Ninja from this episode. Oh, before that, we remove the uh, Python source files. Okay, then extract Ninja. Well, Ninja is a small build system with a focus on speed. Okay, let's see. Okay, so the tip is this. Okay, we are in Ninja now. This section is not strictly required for LFS if not using sysmd. On the other hand, Ninja associated to Meson makes a powerful build system combination, which is expected to be used more and more often. It is required for the several packages in the PLFS. Anyways, let's go ahead and install Ninja. When run, Ninja normally runs a maximum number of processes in parallel. By default, this is the number of cores on the system plus 2. In some cases, this can overheat a CPU or run a system out of memory. If run from command line, parsing a -n parameter will limit the number of parallel processes. But some packages embed the execution of Ninja and do not parse a j parameter. Using an optional procedure below allows the user to limit the number of parallel processes via an environment variable Ninja jobs. For example, running export Ninja jobs equal to 4 will limit Ninja to 4 parallel processes. If desired, add a capability to user environment variable Ninja jobs by running. Okay, but I'll not do that. I will basically add, I would say, a cooling fan before I run it. Hopefully, it will resolve the issue. If desired, add a capability to use environment variable Ninja by running. Okay, I'll not do that. Build Ninja with Python. Python 3 config py bootstrap. Okay, hopefully it should run now. It says like it is 0.2 SPU, which is not a big time to build. Meaning of the build option here, bootstrap. This parameter forces Ninja to rebuild itself for the current system. To test the result, issue Ninja test. And I'm not going to run any of the tests here. It's also warning. A compatible version of RE2C greater than 0.11.3 was not found. Changes to source inc.cc will not affect your build. Okay, let's wait until it finish. Anyways, let's see the contents of Ninja. Okay, Ninja is a Ninja build system. Okay, let's just try to do a little bit of research on Ninja build system because we have something called make build system, make build system. Ninja is similar to that, but let's get some more information on Ninja build. You see, my PC is it's getting probably it is running with all the cores. Basically, Ninja is a small build system with a focus on speed. It differs from other build systems in two major aspects. It is designed to have its input files generated by a higher level build system, and it is designed to run builds as fast as possible. Why yet another build system? Where other build systems and high level languages, Ninja aims to be an assembler. Okay, Ninja build files are human readable but not especially convenient to write by hand. These constrained build files allow Ninja to evaluate incremental builds quickly. To use Ninja, Ninja's low-level approach makes it perfect for embedding into more featureful build systems. List of existing tools. Ninja is used to build Google Chrome, parts of Android, LLVM, and can be used in many other projects due to CMake's Ninja background. Okay, I think Ninja is supported in CMake. See the manual for more philosophical background, whether and how you can use Ninja for your project, platform support, and details about the language semantics. List of existing tools. Okay, it's taking us to GitHub. This page lists generators that can produce Ninja files. Some of them are generally usable. Some are one-off scripts specific to a given project. Okay, it's VFG 9000 is a cross-platform build configuration system with an emphasis on making it easy to define how to build your software. It converts a Python-based build script into the appropriate files for your underlying build system of the choice. Okay, this can generate files for Make, Ninja, or MS Build. Okay, interesting. The Blade build is a powerful declarative multilingual build system. It used to use SCONs and backend, but got notable speed improvements after switching the backend to Ninja. These are all basically the build uh, tools. You can make CMake is a general purpose meta build system. CMake runs on most platforms and can generate project files in many formats, including Ninja. Use Ninja. So I have been using Make CMake. Basically, CMake is a build system that generates make files. If you are using a make format, make if you want to use, if you want to use make build system, but if you use here -g ninja as a parameter to CMake, it will generate files for Ninja. There are a lot of build tools, but it's good to know. Let's learn a little bit of CMake here, uh, because this is something very important for, I mean, any general purpose or embedded development. CMake is an open source cross-platform family of tools designed to build, test, and package software. CMake is used to control the software compilation process using simple platform and compiler independent configuration files, and they generate native make files and workspaces that can be used in the compiler environment of your choice. The suite of CMake tools were created by Kitware in response to the need for a powerful cross-platform build environment for open source projects such as ITK and VTK. Okay, okay, now that the build is done, let's go back. As I said, I'm not going to run the tests. I'll straight away install the packages, the programs. Okay, then install this one, copy and paste it. So here we're going to install the 644 as the the file modes. Okay, the installation is done. Now let's come back to sources and remove the Ninja source files, and let's extract Mason and cd to Mason. Mason is an open source build system meant to be both extremely fast and as user friendly as possible. It's not strictly required, but let's install this package. Let's build it. Installation of Mason. This package does not come with test suite, so after that we're going to install it. Okay, now it's built. This package does not come with the test. Straight away we will install it. Copy recursively the destination folder to the root. Okay, and install. Okay, root dest. Here the root is destination. By default, Python 3 cerebral.py installs various files such as man pages into Python eggs with a specified root location. Setup.py installs these files into standard hierarchy. Then the hierarchy can just be copied to the standard locations. Okay, now let's build core utils. Come back to sources, remove the Mason sources, then tar xvf, sorry, not cvf, it's xvf, it's a typo there. Core utils, ah, dot. Do we have? Okay, since we have a patch, that's why I'm not getting it here. Great, we extracting the patch here. Sorry, the core utils. The core utils package contains utilities for showing and setting the basic system characteristics. These are the core utilities for a Linux system. So let's patch it. Before that, we need to move to core utils directory. And the installation of core utils, the POSIX requires that programs from core utils recognize character boundaries correctly, even in mutable locales. The following patch fixes this non-compliance and other internationalization related bugs. Okay. In the past, many bugs were found in this patch. When reporting new bugs to core utils maintainers, please check first if they are reproducible without this patch. Now we fix the problem with chmod redundant values. Okay, patching. Okay, that's fine. Now prepare core utils for compilation. Here we want to do autoconf. This is where we are using autoconf, which we have built previously. And force unsafe config equal to 1. Okay, autoconf, the patch for the internalization has modified the building system of the package, so the configuration files have to be regenerated. So is it a one command? No. This environment variable allows the package to be built as the root user enable no install program kill uptime. uptime. The purpose of this switch is to prevent codetools from installing binaries that will be installed by the packages later. And if you see the contents of codetools are much more, and I think we have seen all these things in the previous episode. Maybe you can check out my other videos, my earlier episodes. Okay, now the auto conf is done. Now let's run the configuration with these options. Now that the configuration is done, let's make this module. Let's build it. It's gonna take some time. Let's wait until it finishes. And the thing is that I'm not going to run these tests, so we will directly move to install the package step. Okay, now that it is built, let's install the package. Okay, now that the core utils is built, let's move to the next package, chuck. Okay, now that we have built core utils, let's build the package chuck, and then okay, for that let's come to sources, remove the core utils, then extract check, then cd to check. Okay, check is utility is a unit testing framework for C. Okay, it's basically a unit testing framework. Let's compile it. Let's configure for compilation. The contents is check mk, a duplicate script for generating C unit tests for use with check. Now that the configuration is done, let's compile it. And I'm not going to run the test cases, so it will not take much time for the compilation. Okay, now install the package. Okay, and come back to sources. Then remove the uh, chuck sources. Then extract the diff utils. Then cd to diff utils. Then configure for compilation. Here the diff utils contains programs that show differences between the files and directories. Like in Windows, you have this beyond compare, such file comparison or folder comparison tools. The CMP compares two files and reports whether or in which bytes they differ. Diff compares two files directories and reports which lines in the files differ. Diff3 compares three files line by line. SDiff merges two files and interactively output the result. Okay, now let's compile it. Okay, now let's install the package. JAWK. Let's build JAWK module and let's come to sources and remove diffuse sources. Okay, now let's extract our XVF JAWK. Well, the JAWK package contains programs for manipulating text files. Okay, so unneeded files are not there. Okay, let's get into the JAWK directory. Extras are removed. Prepare JAWK for compilation. This is where we configure it with the prefix user, root user. The contents of JAWK are JAWK, a link to JAWK, a program for manipulating text files. It is GNU implementation of JAWK. JAWK one, it's a hard link to JAWK. Okay, and it's not going to take much time, probably a couple of seconds or 1 or 2 minutes. Okay, now that the configuration is done, let's build it. So wait for the compilation to finish. Well, the build is done. Let's install it. As I'm not going to make, I'm not going to run the test cases here. Also, we'll install the documentation. Then let's come back to sources and remove the GAWK module. Sorry, the sources GAWK, and then extract the find details. We're gonna build for find details. CDT find details. The find details package contains programs to find files. These programs are provided to recursively search through a directory tree and to create, maintain, and search a database, often faster than the recursive find, but is unreliable if the database has not been recently updated. Okay, then let's prepare for compilation. Here, if it is I86 time T32-bit, okay, is set, then the configuration. With x86 64, which is in our case, it's just configuring with these options. Meaning of the configuration options. Timer 32-bit, okay, consider setting is needed. This setting is needed for building on a 32-bit system. Local state dir. This option changes the location of the locate database to be in varlib locate, which is FSH compliant. Okay. Contents of find details or find search find. Such as given directory tree for files matching the specified criteria. Locate search through a database of file names and reports the name that contain a given string or match given pattern. Update DB updates the locate database. It scans the entire file system including other file systems that are currently mounted unless told not to, and puts every file name it finds into the database. Exarchs can be used to apply a given command to a list of files. Okay. Okay, now then install it. Sorry, make. Now we're gonna build. It's going to take a couple of seconds. Let's wait. Well, now the tests are done. Sorry. Well, the build is done. Let's run install. I'm not going to run the test cases. The next module that we're going to install is the graph. The graph package contains programs for processing and formatting text. Okay, then come back to sources, remove defined util, then tar xvf graph package, then cd to graph package. Installation of graph expects the environment variable pace to contain the default pager size. For users in the United States, page equal to letter is appropriate, elsewhere page A4 may be suitable, while the default page size is configured during compilation. It can be overridden later by encoding either A4 or letter to the etc paper size file. Okay, so what we will use is what I'm going to use is A4. A4. Okay, contents of graph. Okay, it has pretty some fun programs here. They show descriptions, add add a file info, ft info, reads a tar front file and add some additional front metric information that is used by the graph system. AFM2DIT creates a front line for use with graph and graphs. CHEM graph preprocessor for producing chemical structure diagrams. EQN compiles descriptions of equations embedded within trough input files into commands that are understood by trough. Equine to graph converts star graph EQN equation into a cropped image. G, GDiffMK marks difference between graph and graph files. G LilyPond transform sheet music written in the LilyPond language into graph language. G Perl preprocessor for graph allowing addition of Perl code into graph files. G PinYIN prepares for graph sorry preprocessor for graph allowing addition of Chinese European-like language pinyin into graph files. Okay, now let's build with make-j1. They say it is not supports parallel execution. The graph to graph converts a graph program into cropped bitmap image. GRN, a graph preprocessor for Gremlin files. GrowDVI driver for graph that produce text DVI format. Graph a frontend to the graph document formatting system. Normally it runs the draft program and post-processor appropriate for the selected device. Grapher displays graph files and man pages on X and TTY terminals. Grog reads files and guesses which of the graph option E, man, ME, MM, MS, P, and S and T are required for printing files and reports the graph command including these options. Grow LBP is a graph driver for Canon CAPSL printers, LPB4 and LP8 series laser printers. Growl J4 is a driver for graph that produces output in PCL5 format suitable for HP LaserJet 4 printer. Graph DF translates the output of GNU Draft to PDF. Grops translates the output of GNU Draft to PostScript. Grotty translates the output of GNU Draft into a form suitable for typewriter-like devices. HP FTDoit creates a front file for use with graph DLJ4 from an HP tagged front metric file. IndexBib creates an inverted index for bibliographic databases with a specified file for use with refer, look, bib, and lkbib. Lkbib searches bibliographic databases for references that contain specified keys and reports any references found. Look, bib prints a prompt on the standard error unless the standard input is not a terminal, reads a line containing a set of keywords from the standard input, searches the bibliographic databases in a specified file for reference containing those keywords, prints any reference found on the standard input, and repeats this process until the end of input. mmgraph, a simple precursor for graph. NEQN, in NEQN formats equations for American Standard Code for information interchange. ASCII output. ngraph script that emulates the ngraph command using graph. PDFMOM is a wrapper around graph that facilitates the production a PDF document from files formatted with the MOM macros. PDF RAW creates PDF document using graph P, PFP tops, translate a PostScript front in .pfb format to ASCII PIC, compiles description of structures embedded within TORF or TX input files into commands understood by text or TORF. Pic to graph converts a pic diagram into a cropped image, translates the output of GNU TORF to HTML. Recon converts encoding of input files to something GNU TORF understands. Pre-growth HTML Pre-grow HTML translates the output of GNU TORF to HTML. Refer copies the contents of a file to the standard output execute, except that lines between dash open square braces and dot in square braces are interpreted as citations, and the lines between dot r1 and dot r2 are interpreted as commands for how citations are to be processed. RAW to div transforms RAW files into div format, and RAW to HTML into HTML format, RAW to PDF to transform files into PDF, RAW to PS transform RAW files into PS files, RAW to text transforms RAW files into text files, RAW to X RAW transforms the RAW files into other formats. Soilim reads files and replaces lines of the form.so file by the contents of the mentioned file. TBL compiles descriptions of table embedded within TROF input files into commands that are understood by TROF. tfm2dit creates a front file for use with graph tdvi. TROF is highly compatible with Unix TROF. It should usually be invoked using the graph command, which will also run preprocessor and postprocessors in the appropriate order and with the appropriate options. Okay, so if you see this, what we understand is this is the program for processing and formatting text, and how Linux sees text files and page, basically formatting the page of your content. It's quite interesting. Okay, let's wait for the compilation to finish. Well, now it's done. Now let's install the package. The next package that we want to build is grub. The grub package contains the ggrand unified bootloader. I will come back to sources and icon order graph. Okay, so let's extract grub, and, and grub. If you see, we have grub, you can have multiple uh, bootloaders. Okay, sorry, it's a bootloader that can be used to boot different operating systems. If you want to do, let's say, parallel, not parallel, I would install the OS side by side, and then you can choose which operating system to load. Let's configure for installation of grub. If your system has UEFI support and you wish to boot LFS with UEFI, you can skip this package in LFS and install grub with UEFI support and its dependencies. That's fine. I'll go with the normal configuration. Contents of grub BIOS setup. It's a help program for grub install. Grub edit env, a tool to edit environment block. Grub file checks if file is of the specified type. EFS test tool for debugging the file system driver. Blue EFI processes 32 and AMD 64 EFI images and glues them according to the Apple format. Install grub on your device. Grub kbd comp script that converts an XKB layout into one recognized by grub. Grub MCB sorry MAC bless max style bless on FSH or on HFS or HFS plus files. Grub menu LST to conf CFG converts a grub legacy menu.lst into a grub.conf CFG for use with grub 2. Grub make mkconfig generates a grub config file. mkimage makes a bootable image of grub. mklayout generates a grub keyboard layout file. mknetdir prepares grub netboot directory. Grub mkpassword pbkdf2 generates an encrypted pbkdf2 password for use in the boot menu. Grub make mk real path make system path name relative to its root, its relative path. Grub make mk rescue makes a bootable image of grub suitable for a floppy disk or CD-ROM or DVD. Grub mk standalone generates a standalone image. Grub of path name is a helper program that prints the path of a grub device. Grub probe provides device information for a given path or device. And now make -g to take the parallelism. Okay, listen here. The grub probe is done. Grub probe device information for a given path or device. Grub reboot sets the default boot entry for grub for the next boot only. Grub render label render apple.disk label for Apple Macs. Grub script checks grub configuration script for syntax errors. Grub set default sets the default boot entry for grub spark 64 setup. It's a program for setup grub setup. Grub sys linux to conf cfg transfer the syslink config file into grub.cfg format. And now we will wait for the compilation. Finish. Well, now that the build is done, let's install. Also move this etc bash completion.d files to grub to user share. Okay, no problem. User share bash completions. Okay, okay. Now the next module is gzip. So come back to sources, remove the gzip, sorry, the grub sources, then tar xvf gzip, configure, before that cd2 gzip, then paste configuration, contains contains unzip decompression zip files. gz.exe creates a self decompressing executable file. gzip compresses the given file using lample civ lz77 coding, uncompress decompress compressed files. zcat decompresses the given zip files to standard output. zcmp runs cmp on zipper files. zdiff runs diff on zipper files. zegrep runs egrep on zipper files, runs fgrep on zipper files. That forces a .gz extension on all given files that are zipped files so that gzip will not compress them again. This can be useful when file names were truncated during a file transfer. zgrep runs grep on gzipped files. zless runs less on gzipped files. zmore runs more on zipped files. zneo recompress files from compressed format to gzip format. .z .gz. Okay, now let's compile. It's not going to take much time, hopefully. Okay, then we do let's install this package, and we're not going to run the test here. Okay, now it's installed. Now let's come back to sources, remove the gzip sources, then extract the IP route, IP router 2, then cdt IP router 2, The IP router 2 package contains programs for basic and advanced IPv4 based networking. Okay, this is a networking package, I would say. The ARPG program included in this package will not be built since it is dependent on Berkeley DB, which is not installed in LFS. However, a directory for RB and a man page will still be installed. Prevent this by running the command below if the RBD binary is needed. Instructions for compiling the Berkeley DB can be found in the BLFS book, but we're not going to do that. Let's update the makefile and then remove the man pages for RB. Then let's straight away make the IP router contains these programs: bridge config network bridges, CT-stat connection status utility, GNL generic netlink utility frontend, IFCFG shell script wrapper that for the IP command. Note that it requires ARPing and RDisk programs from the IPutil package found at IFStat shows the interface statics including the amount of transmitted and received packets by interface IP. The main executable, it has several different functions. IP link device allows user to look at the state of the device and to make changes. IP address allows user to look at address and their properties, add new address and delete old ones. IP neighbor allows users to look at neighbor bindings and other properties and new neighbor entries and delete old ones. IP role allows user to look at routing policies and change them. IP route allows user to look at routing table and change routing table rules. IP tunnel allows users to look at IP tunnels and their properties and change them. IP ADDR allows to look at multicast address and their properties and change them. IP mroute allows user to change and delete the multicast routing. IP monitor allows users to continuously monitor the state of a device, addresses and routers. LNstat provides Linux network statics. It is a generalized and more feature complete replacement for the old rstat program. Nstat shows network statistics. Route F component for IP route. This is for flushing the routing tables. Route L component of IP route. This is a listing the routing table. RTACT displays the contents of PROCnet RTACT. RTMon route monitoring utility. Okay, now that the build is done, so we are going to run the install. Okay, and let's install the documentation also. Well, now we were in the rstat route status utility. This is similar to the netstat. Command shows active connections. TC, traffic controlling executable. This is for quality of service QoS and class of service EOS implementations. TC queue disk allows users to set up queuing discipline. TC class allows users to set up classes based on the queuing displaying scheduling. So discipline scheduling. TC estimator allows users to estimate the network flow into a network. TC filter allows users to set up the QoS COS pocket filter. TC policy allows users to set up the QoS and COS policies. Now that we have built the IP route, okay, we have built the IP route. Let's start KBT. Before that, we will remove the IP route, then extract the KBT package. Okay, it has a patch. Then anyways, we will apply the patch now. CD to KBD, and let's apply the patch. And while applying the patch, let's see. The KBD package contains key table files, console fronts, and keyboard utilities. Approximate build time is okay, 0.1 SPU, and it required disk space is 33 MBs. The behavior of the package and the delete key is not consistent. Okay, backspace and delete key not consistent across the key maps in the KBD package. The following patch will fix this for I386 key maps. After patching the key backspace and the key generates the character with the code 127, and the delete key generates well-known escape sequence. Remove the redundant resize cons program. It requires the defunct svg alib to provide video mode files for normal use. Set font size the console appropriately together with its man page. Basically, we're inserting this configuration and we're inserting this to make file. Okay, prepare KBT for compilation. Meaning of this: disable vlock. This option prevents the vlock utility from being built because it requires PAM library which isn't available in the ch root environment. Okay. The contents of KBD are there are quite a few programs. CHVT changes the foreground virtual terminal. Dalloc VT deallocates visual unused virtual terminals. Dump keys dumps the keyboard translation tables. EFG console prints the number of the active virtual terminal. Okay, now that the configuration is done, then let's build with make j. Okay, we were at key fg console prints the number of active virtual terminals, get key codes prints the kernel, scan code to key code mapping table, KBD info obtains information about the status of a console, KBD mode reports or sets the keyboard mode, keyboard rate sets the keyboard repeat and delay rates, load keys loads the keyboard translation table, load UNI map loads the kernel Unicode to font mapping table, map screen, an obsolete program that used to load a user-defined output character mapping table into a console driver. This is now done by set font. OpenVT starts a program on a new virtual terminal. Okay, there are a lot of programs. PSF ADD table adds a Unicode character table to a console font. PSF get table extracts the embedded Unicode character table from a console font. PSFS table removes embedded Unicode character table from Unicode or from a console font. PSFX table handles Unicode character table for console fonts. Set font changes the enhanced graphic adapter, EG and video graphics array. VGF fonts on the console. Set key codes loads kernel scan code to key code mapping table entries. This is useful if there are any unusual keys on the keyboard. Okay, these are all basically keyboard utilities. Okay, show keys reports the scan code, key codes, and ASCII codes of the key pressed on the keyboard. Okay, I think I have used show key where it will display whatever we pressed onto the screen. Okay, now that we will install it. For some language example, Belarusian, the KBD package doesn't provide a useful keymap where the stock by keymap assumes the ISO 8859-5 encoding and the CP1251 keymap is normally used. User of such language have to download working keymaps separately. Okay. You decide install the documentation. Let's install the documentation. Okay. Now that we have built and installed, let's move to lib pipeline. Come back to sources, remove the KBD and extract lib pipeline. Let's configure this lib pipeline for build. Assort cd to lib pipeline, and then we configure it for the build. The lib pipeline package contains library for manipulating pipelines of subprocess in a flexible and convenient way. Okay. Lib pipeline. This library is used to safely construct pipelines between subprocesses. Okay. The pipeline is basically, at least in the terminal, you have this pipeline where you can pass the output of one command to the next command that you want to execute. Okay, then compile it. J. Then we install it. Now that the lib pipeline is done, let's come back to sources and remove the lib pipeline sources. Then extract xvf make, then cd make, then configure make for compilation. The make package contains a program for controlling the generation of executables and other non-source files of a package from the source files. Whatever we are making, whatever we're building, the LFS or the sources uses the make framework. Contents of make is automatically determines which piece of package needed to recompile and then use the relevant commands. Okay. The advantage of make is, let's say, when you have hundreds of source files and you change only a particular source file using make, you can compile only that and link it. They basically make detects that only a one particular source file is changed and then the relevant files are compiled, not the whole project. So that's the main advantage, and it also offers a lot of advantages with respect to passing compiler flags and other stuff. Yes, let's build it. And we install it. Okay, now let's move to patch package. Come back to sources and then remove the make sources. Then extract the patch cd to p patch. Then let's configure the patch for compilation. The patch package contains a program for modifying and creating files by applying a patch. It's typically created by diff program. Okay. Contents is basically the same thing, which is described above. Okay, now let's install. Let's think need to build it. Sorry, let's build this package. Okay, now let's install. The next module that we're going to build is star. Before that, we remove the patch and then tar extract xvf tar and cd to tar package. Prepare for the configuration. Force unsafe configure equal to 1 and then configure. Why are they setting this environment variable? Okay, before that we'll see the tar package provides the ability to create tar archives as well as perform various other kinds of archive manipulation. Tar can be used on previously created archives or to extract files, to store additional files, or to update or list files which are already stored. Okay. The meaning of the configuration option. The force unzip configure equal to 1. This forces the test for MKA node to be run as root. It is generally considered dangerous to run this test as a root user, but as it's being run on a system and can only be partially built, overriding is okay. Anyways, we're not going to run the check, but that's fine. The tar creates, extracts files from and lists the content of archives, also known as tarbars. Let's see where are we at in building this the basic system software. Now we are period kit. Okay, now we are at this point. Still a few more modules to be, few more packages to build. Hopefully in this episode I can finish these modules or packages. Vim, okay, text info Vim. Vim is a very good utility or a text editor. Okay, let's see. Tar is going to take 1.7 SPU. Okay, let's compile it. Let me give a number. Let's say text. Okay, the compilation is done. Then let's make install. Oh, not going to run the tests. Also, we'll install the documentation. The text info package contains program for reading, writing, and converting info pages. Okay, the next package that we would install is text info. For that, let's come back to sources and then remove the mm, tar xvf text info not rex. It's text typo. Cd text info. Then let's configure this for compilation. Again, fix an issue building the package with glibc 2.34 or later. Okay. The text info contents are like info used to read info pages which are similar to man pages but often go much deeper than just explaining all the available command line options. For example, compare man bison with info bison. Okay, let's see later. Install info. Used to install info pages. It updates entries in the info index page. Make info translates given text info document into pages. Info plain text or HTML. Just conversions here. index text index is to short text info index files. Okay, okay, let's fix this issue. Fine, and then let's compile it. Building these packages is a little boring, I would say. You have to just enter commands and watch the screen. Not that fun, but here and there you get to learn few things. That's the advantage. Also, that's the purpose of undertaking this LFS project, I would say. Okay, then let's install. Optionally install the components belonging to text installation. Okay, the here text mf user share text mf. The text mf make file variable holds the location of the root of the text tree. If, for example, text package will be installed later. Okay. The info documentation system uses a plain text file to hold its list of menu entries. The files is located at user share info.dir. Unfortunately, due to occasional problems in the makefiles of various packages, it can sometimes get out of sync with the info pages installed on the system. If the user share info.dir file ever needs to be created, the following optional commands will accomplish the task. Okay, let's create this first. Okay, now let's install Vim. Come back, then rm text info sources, then extract Vim. Vim package contains a powerful text editor. Alternatives to Vim, if you prefer another editor such as Emacs, Joy, or Nano, okay, that's fine. Vim is a good editor. First, change the default locations of the Vim RC configuration file to etc. Okay, oh, sorry. Let's go to Vim. Then prepare Vim for compilation. But I'm not going to run the tests. I will build and install. Let's see the contents of Vim. Install packages ex, starts Vim in ex mode, review, ls is restricted version of view, sorry, is a restricted version of view. No shell commands can be started and view cannot be suspended. Or Vim is restricted version of Vim. No shell commands can be started and Vim cannot be suspended. Vi link to Vim. View starts Vim in read-only mode. Vim is an editor. Okay, now let's compile this. Okay, the next is just compile, and here Vim diff edits two or three versions of a file with Vim and show differences. Vim tutor teaches the basics, keys and commands of Vim. XXT creates help dump of the given file. It can also do the reverse, so it can be used for binary patching. Okay, after the make, we will install. It's going to take some time. Let's wait because it's a little bit bigger module, bigger package. Let's wait until the build is done. Build is done. Now let's install. When users to using VI instead of Vim to allow execution of Vim when users habitually enter VI, create a symbol link for both the binary and the man pages to provide the languages. Provided languages. Okay. It's basically Vim with VI. By default, Vim's documentation is installed in user share Vim. The following symlink allows the documentation to be accessed via user shared doc vim 8.2.8343, making it consistent with the location of documentation for other packages. Okay, if an X we're going to do that, that's fine. Let's configure Vim. By default, Vim runs in VI incompatible mode. This may be new to users who have used other editors in the past. No compatible setting is included below to highlight the fact that a new behavior is being used. It also reminds those who would change to compatible mode that it should be the first setting in the configuration file. This is necessary because it changes other settings, and overrides must come after the setting. Create a default Vim configuration file by running the following. Okay, here set no compatible setting makes Vim behavior in a more useful way, the default than the VI compatible manner. Remove the no to keep the old VI behavior. The set backspace to settings allows backspacing and overline breaks, auto indents, and start of an insert. The syntax on parameter enables Vim syntax highlighting the set most equal to setting enables proper pasting of text with the mouse while working in chroot or over a remote connection. Finally, the if statement with the set background equal to doc setting corrects Vim's GUSS about the background color of this some terminal emulator. This gives highlighting a better color scheme for use on a black background of these programs. Okay. The documentation for other available options can be obtained by running the following command. vmc option. Let's see what it has to offer. Okay, okay, let me exit. Quit forcefully. Okay. By default, Vim only installs spell files for English language. To install the spell files for your preferred language, download the .spl and optionally .sug files for your language and character. Okay, I think for us SPL is fine, and set spell. Okay, okay, that's fine. Now we configured the Vim. Come back to sources and remove the Vim source. Then extract udev udev. The udev package contains programs for dynamic creation of device nodes. Okay, cd udev, the prepare for configuration or prepare for compilation. Let's see what it contains. Or UDEV EDM, generic UDEV administration tool, controls the UDEV daemon, provides info from UDEV database, monitors UDEV, U events, waits for U events to finish, tests UDEV configuration, and triggers U events for a given device. UDEV daemon that lists for events on the netlink socket, creates devices, and runs the configured external programs in response to the U events. libudev and etcudev. Okay, these are just libraries. Okay, now that the configuration is done, let's compile it. Anyways, I'm not going to run tests. That means these two steps are not needed. So I can straight away install this package. Okay, now that it's made, built, let's install. Install some custom rules and supports files used in LFS environment. Okay, and make things to install. Okay, okay, fine. Now let's install the man pages like mandb man pages database. Then come back rm-rf eu dev, then extract mandb. ManDB package contains programs for finding and viewing man pages. Okay, let's go to ManDB and prepare ManDB for compilation. Meaning of this configuration options: disable set UID. This disables making the man program set UID to user man. Enable cache owner equal to bin. This makes the system-wide cache files be owned by user bin. With all these browser, bgrind, grep, sys. These three parameters are used to set some default programs. Links is a text-based web browser. See BLFS for installation instructions. vgrind converts program sources to graph input, and graph is useful for typesetting graphs in a graph environment. Graph document. The vgrind and graph programs are not normally needed for viewing manual pages. They're not part of LFS or BLFS, but you should be able to install them yourself after finishing the LFS if you wish to do so. With systemd, the, these parameters prevent installing unneeded systemd directories and files. Okay, non-English manual pages. The following table shows the character set that ManDB assumes manual pages installed under user share man ll. This directory will be encoded with. In addition to this, ManDB correctly determines if manual pages installed in that directory are UTF-8 encoded. Okay, there are a lot of uh, languages supported. Contents of ManDB. AccessDB dumps what is database contents in human readable form. APROP searches what is database and displays the short descriptions of system commands that can contain a given string. Catman creates or updates the pre-formatted manual pages. Log lgxgrog displays one-line summary information about given manual page. Man formats and displays the requested manual page. Man recode converts manual pages to another encoding. ManDB creates or updates what is database. ManPath displays the contents of ManPath, or if ManPath is not set, a suitable search path based on settings of man.conf and the user's environment. What is searches the what is database and displays the short description of the system commands that contain the given keyword as a separate word. Okay, now that the configuration is done, let's compile this. We're going to run the tests, so we will install once it is done, once the build is done. Now we are in man pages. We're almost done with the building or installing the programs, applications. Let's see. Here, the easy part is just building it. Probably the tricky part is system configuration and making the LFS system bootable. These are things that are tricky and needs to go right. Okay, the compilation is done. Now let's install. The next module that we want to build or is pros- proc.ps. Before that, we remove the mandb, then extract proc.ps.ng, cd proc. Okay, okay, proc.ps.ng. Okay, proc.ps 3 dot. Okay, then let's configure this for the build. This package extracts to the directory. Okay, not the expected. Okay, installation of proc.ps.ng. Okay, the meaning of this configuration option is disable kill. This switch disables building the kill command that will be installed by the util Linux package. Okay, the contents are like the process utilities for working with the process. The free is reports the amount of free and used memory in the system. pgrep looks a process based on their name and other attributes. PID off reports PIDs of given programs. pkill signals processes based on their name and other attributes. Pmap reports the memory map of the given process. Now let's build it. PS lists the current running process. Pwait waits the process to finish before executing. PWDX reports the current working directory of a process. slabtop displays the detailed kernel slab cache information in real time. sysctl modifies kernel parameters at runtime. tload prints a graph of the current system load average. Top displays the list of most CPU-intensive processes. It provides an ongoing look at process activity in real time. Uptime routes how long the system has been running, how many users are logged in, and the system load averages. vmstat reports virtual memory statistics giving information about process memory paging, lock input output, traps, and CPU activity. W shows which users are currently logged on, where, and since when. Watch runs a given command repeatedly, displaying the first screen full of its output. This allows a user to watch the output change over time. Okay, libproc contains the functions used by most programs in this package. Okay, now that it's done, let's install. Okay, it's installing the. Okay, let's come back. rm rf proprius 3.7. Okay, then extract the util Linux, the Linux utilities basically. The util Linux program contains miscellaneous utility programs. Among them are utilities for handling file systems, consoles, partitions, and messages. Okay, now cd to util Linux and prepare util Linux for compilation. The hyphen disable and without operations prevent warnings about building components that require packages not in LFS or inconsistent with programs installed by other programs. Okay, okay, here disable login, no login, SU, set private, run user, pilot mount, static Python, systemmd, systemmd, system unit dir. Okay, some of the programs are already installed, some are not needed by LFS, so it's fine. Okay, if desired, run the test suite as a non-root user. Warning. Running the test suite as a root user can be harmful to your system. To run it, the con config SSL debug option for the kernel must be available in the currently running system and must be built as module. Building it into kernel will prevent booting. For complete coverage, other BLFS packages must be installed. If desired, this test can be run after rebooting into completed LFS system and running this. So what I will do is I'm not going to run any tests right now. We will run in case we need it. Okay, now the configuration is done. Let's build it. And no test will be run. So I will not install this. So the contents of util-linux or add part informs Linux kernel of new partition, HTTY, opens HTTY port, prompt for login name, and then invokes the login program. Block discard sectors on a device. Buildkit, a command line to locate and print block device attributes. Block zone runs zone command on the given block device. Block div allows users to call block device IOCTLs from the command line. Cal displays a simple calendar. CFDisk manipulates the partitions table of a given disk. I have used this. CHCPU modifies the state of CPUs. A lot of programs that comes with this utilities. Okay, let's wait for the compilation to finish. Okay, let's install this package programs. Installation is done. Okay, now that the util Linux is built, let's remove uh, the util sources and extract the e2f tar xvf e2 e2f e2fs procs. I think it looks built. It's going to take a little bit of time. 4.4 SB on the spinning disk, 1.0 SB on the STD. Okay, what I have is a spinning disk, so it will take more time. The etfs proc package contains the utilities for handling the ext2 file system. It also supports ext and ext4 journaling systems. Okay, let's go to the e2 e2fs procs, and the e2fs procs documentation recommends that the package be built on a subdirectory of the source tree. So let's go to cd build, because I can paste copy, I can type it. So then the prepare for configuration, sorry, prepare for build. Meaning of the configure options: enable elf shlibs. This creates the shared libraries which some programs in this package use. Disable, like, this prevents etfs procs from building and installing the libuid and lib lkid libraries and uid daemon and the fsck wrapper as the util Linux installs more recent versions. Okay, next I'm gonna build and install. Let's see the contents of etsprog. Bad blocks searches a device, usually a disk partition for bad blocks. C charter changes change attribute, changes the attributes of files on an ext2 file system. It also changes ext3 file system, the journey version of ext2 file systems. Compile et an error table compiler. It converts a table of error code names and messages into a C source file suitable for use with COM error library. Okay, now we build it. Make -j4. Then the debugfs, a file system debugger. It can be used to examine and change the state of an ext2 file system. Dump e2fs prints and superblock and blocks group information for the file system present on a given device. e2 e2 free frag reports free space fragmentation information is used to, okay, e2fsk is used to check and optionally repair e2fs2 file systems and the etx3 file systems. e2 image is used to save critical e2xt ext2 file system data to a file. e2 label displays or changes the file system label on the eTXT file system present on a given device. E2 MMP status checks the MMP status of an ext4 file system. E2 scrub checks the contents of mounted ext234 file systems. Okay, suppose E2 ext2, 3 and 4. E2 scrub all checks all mounted ext file systems for errors. E2 undo replace the undo log for an ext234 file system found on a device. This can be used to undo a failed operation by an E2fprogs program. Okay, E2 E4 crypt ext4 file system encryption utility. E4 defrag online defragmenter for ext4 file system. File frag reports how badly fragmented a particular file might be. fsk.ext2, fsk.ext3, and ext4 by default checks ext2 file system and is a hard link to e2fsk. Okay. Log save saves the output of a command in a log file. ls attribute lists the attributes of files on a second extended file system. mk commands converts a table of command names and help message into C source file suitable for use with the libss subsystem library. mk2fs creates an ext2 or ext3 file system on the given device. mk start ext2 by default creates ext2. In this ext3 by default creates ext3 file system, and this mkfs.ext4 by default creates an ext4 file system and is a hard link to make2fs. mk lost plus found used to create a lost plus found directory on an ext2 file system. It pre-allocates disk blocks to this directory to lighten the task of e2fs disk e2fsck. Resize 2fs can be used to enlarge or shrink an ext2 file system. Tune 2fs adjusts tunable file system parameter on an ext2 file system. Okay, now that the build is done, let's install. I'm not going to run the test here. Remove the useless static libraries. Okay, and this package installs a gzipped.info file but doesn't update system-wide dir file. Unzip this file and then update the system dir file using the following command. Okay, we're going to unzip this file and install the info to these particular directories. Okay, if desired, create and install some additional documentation by issuing the following command. Okay, let's install. Okay, now that we're finished with the etfs prog, then move on to syslog-d. So let's come back to sources, remove the E2 fsprog source directory, then extract this is k log d, then cd to sys k log d. The syslog-d package contains programs for logging system messages, such as those given by the kernel when unusual things happen. Okay, in order to install, we need to do something here. First, fix problems that causes a segmentation fault under some conditions in klogd, and fix an obsolete program construct. Okay, then here, okay, now let's compile it. Now that the package is built, let's install the same. Okay, now it's installed. We need to configure the syslog, create new etc syslog conf file by running the following command. Okay, okay. So basically, contents of syslog is a system daemon for interpreting, intercepting, and logging kernel messages. Klogd. Syslog logs the messages that system programs offer for logging. Every logged message contains at least a date stamp and host name, and normally the program's name too, but that depends on how trusting the logging daemon is told to be. Okay, but here in the configuration, it is mostly to do with uh, it's the kernel log, mail log, and user log, syslog, and author log. So these things are to be captured in these logs. That's the reason I think uh, we have this file, syslog. Now let's come back, then remove the sys klog p, then extract sysv init. Looks like there is a patch. Then cd to sysv init. The sysv init package contains programs for controlling the startup, running, and shutdowning of the system. Okay, there is a patch. We have to patch this before building. First, apply the patch that removes several programs installed by other packages, clarifies the message, and fixes a compiler warning. Okay, then we build this. Contents of sysvinit: boot logs boot messages to a file. fstab decode runs a command with fstab encoded arguments. Halt normally invokes shutdown with the H option, except when already in run level 0. Then it tells the kernel to halt the system. It notes in the file where log wtmp that system is being brought down. Now let's install the same. We have init, the first process to be started when the kernel has initialized the hardware, which takes over the boot process and starts all the process specified in its configuration file. Kill all 5 sends a signal to all process except the process in its own session, so it will not kill its parent shell. Power off tells the kernel to halt the system and switch off the computer. See halt. power off. Okay, then the reboot tells the kernel to reboot the system. Run level reports the previous and current run level as noted in the last run level record. In run UTMP shutdown brings the system down on a secure way, signaling all processes and notifying all logged in users. Tell init this tell init which run level to change to. Okay, great. So now that we have built all the modules that were all the packages that are part of the basic system software. So this completes just let's say the building part. The next we will see a little more about debugging and other stuff. In this chapter we have okay about debugging symbols. Most programs and libraries are by default compiled with debugging symbols included with gcc-g option. This means that when building a program or library that was compiled with debugging information, the debugger can provide not only memory address but also the names of the routines and variables. However, the inclusion of these debugging symbols enlarges a program or program significantly. The following is an example of amount of space these symbols occupy. A bash binary with debugging symbols 1200 kbs. A bash binary without debugging it's 480 kb. The glibc and gcc files with debugging symbols 87 MB, GCC and glibc and GCC files without debugging will just be 16 MBs. So it takes a lot of memory. The sizes may vary depending on which compiler and C libraries were used, but when comparing programs with and without debugging symbols, the difference will usually be a factor between 2 and 5. Okay, because most users will never use a debugger on their system software, a lot of disk space can be retained by removing these symbols. The next section shows how to strip all debugging symbols from the programs and libraries. Okay, now let's stripping. This section is optional if the intended user is not a programmer and does not plan to do any debugging on the system software. The system size can be decreased by about 2 GB by removing the debugging symbols from libraries and binaries and libraries. This causes no inconvenience other than not being able to debug the software fully anymore. Most people who use commands mentioned below do not experience any difficulties. However, it is easy to make a typo and render the new system unusable. So before running this strip command, it is a good idea to make a backup of the LFS system in its current state. The debugging symbols for selected libraries are placed in separate files. This debugging information is needed if running regression tests that uses Valgrind and GDB later in BLFS. Note that strip will overwrite the binary or library file if it is processing. This can crash the process using code or data from the file. If the process running strip itself is affected, the binary or library being stripped can be destroyed and can make system completely unusable. To avoid it, we'll copy some binaries and libraries into temp, strip them there, and install them back with the install command. Read the related entry, upgrade issues for the rationale to use the install command here. Okay, so as we programmers, I'm not going to strip it. So I will not strip this instance of LFS. So I'm going to skip this. Finally, I'm going to skip the stripping part because I won't have the debugger debugging support. Finally, clean up some extra files left around from running tests. So let's come back. Paste, remove the order. The temp directory is removed. There are also several files installed in the user lib and user lib exit directories with a file name extension of .le. These are libtool archive files. As already said, they are only useful when linking with static libraries. They are unneeded and potentially harmful when using dynamic shared libraries, especially when using a non-AutoTools build system. To remove them, run this command. Okay, we're going to remove this. Okay, for more information about the libtool archive files, that's fine. The compiler build 6 and 7 is still partially installed or not needed anymore, so remove it. The compiler installed and okay is still partially installed and not needed anymore because we have built the compilers for ourselves. Okay, then finally remove the temporary tester user account created at the beginning of the previous chapter. Okay, that's fine. So if it's not, I think we have not created it. The tester mail support. Okay, the mail is not configured. Okay, so now that we have the system built, that's it for this episode. And in the next episode, we will see system configuration and probably will complete the LFS. So, so please subscribe to this channel and leave your valuable comments in the comment section. Thanks for watching.